What's your exponent rules? Any exponent rule? Anybody? Anybody? When you multiply bases, you add exponents. What else? When you divide exponents, you subtract, or when you divide like bases, you subtract exponents. Okay. What else? Yeah, power to a power, so like x squared to the 5th power would be what? X to the 10th, all right, that's an important one for today. 2 more. So like I want to go from that into that. So what exponent does that for you? So negative exponent, so x to the negative 2nd is the same as 1 over x to the 2nd. We need that one too. One more that we need today. Something to the effect, some exponent does that. What is that?
0.
Yeah, 0 exponent does that. Alright, so we need to know all these to be able to make this stuff work. We had those steps up there on the, you can't see them right now. But the whole idea is that we make the bases the same. Because once the bases are the same, that means we can only have to worry about the exponents. Now the rules I gave you, those steps up there are just suggestions. I mean, you don't have to follow those suggestions. They just are the easiest way to think about it. So you always want to take the bigger number and make it smaller because that's easier to think about. So what that means on this problem is that we want to leave the 7 alone because you can't go any lower than 7. Okay, when you're talking about messing with exponents. But you can definitely write 49 as 7 to some power. So 49 is 7 to what power? Squared. And so then what is our power to a power rule? We just did it. Multiply. So then the right hand side of this we can write as 7 to what? 2. To what? Well, what's 2 times x? 2x, okay. What's the exponent on the left-hand side? There's not one there. What? Huh? Not 0. If it was 0, then the left-hand side would be 1. So it's just 1, okay, so you can't forget about that either. Right, everything has an exponent. So now the way you want to think about this is that an equation says that the left-hand side is equal to the right-hand side. Well, if that's true, then 7 to some exponent has to be the same as 7 to the other exponent. Does that make sense? Otherwise, these two sides would be different. If you raise 7 to 2 different numbers, then they wouldn't give you the same thing, and then they wouldn't be equal. Does that make sense? Okay, so then you can essentially just ignore the bases now, and you can just say, well, 1 has to equal 2x, and now you have a real simple problem to solve. So we can divide by 2, and x equals 1/2. This is really easy to check because you just plug it back in. And you can ask your calculator, 49 to the 1/2 power, does that equal 7? Well, if you were listening before, someone said, well, isn't that just the square root? And that's true. So 40 is the square root of 49 7? Yeah. Okay, so then is 49 raised to the 1/2 power 7? Okay, so there we go. Is that okay? So you can mess with any side that you want, but I'm going to mess with the side that has the bigger number because I think it's much more easier to think about. So that means we're looking at 1 over 81. We need to rewrite this, and we don't have to do it in one step. In fact, we're going to do it in 2 steps. But we want to write 1 over 81 as 3 to some power. So what do you want to start with?
question again?
Well, so we have to write 1 over 81 as 3 to some power so that we can ignore the bases and just mess with the exponents. But I want to do this in more than one step. Okay, so she's saying 81 is really 3 to the power of 4. So then we can change this. Is this okay with everyone? That these two things on the right-hand side are equivalent? Right? 1 over 81 is the same as 3 to the 4th, or I'm sorry, is 1 over 3 to the 4th? Does that make sense? But the bases aren't the same. The one on the left is a 3, the one on the right is a 1/3. So I'm going to leave this side alone. But I can't just do that because 3 to the 4th is not the same as 1 over 3 to the 4th. So what do we need to add to all this?
You square it?
Well, it's not squared. So again, the idea is that, you know, each of these steps, right, from this one to this one, these two, this right-hand side is the same. 1 over 81 is the same as 1 over 3 to the 4th. Okay? So we got to keep that going. These two numbers here had to be equivalent. Right now they're not, because this one says 1 over 81 and this one says 81. So we have to add something out here so that these two things give us both 1 over 81. All right, well, okay, so that's the final thing, but I'm going to write it as -1 right now, okay? Is that okay? Now the exponent rules say multiply those exponents, so the ultimate thing is what she said there. So this is 3 to the x over 3, or equals 3 to the -4. Again, there's no way that these two sides of this equation can be equivalent without the exponents being equivalent. So then you just set the two exponents equal to each other, and now this one's done already. So x equals -4. So, you know, if you type into your calculator 3 to the -4th, it's going to give you some decimal, and that decimal will be the same as if you did 1 over 81. Is that okay? Side. So the left-hand side, we can write that base of 4 as what? Why did you pick the left-hand side?
There's no reason for it.
Oh, no, well, there's a reason. There should be a reason. What's the reason that the left-hand side is the one we want to mess with?
It's a bigger number.
Yeah, it's the bigger number, so it's easier to go down as opposed to try to go up. You don't have to. If you're going up, you got to mess with fractions right away. So going down, you just got to rewrite it. So what's the only thing 4 can break down to? Yeah, it could be 2 squared, right? Right, because 2 squared is the same as 4, yeah? Okay. So then the exponent rule says what on the left-hand side? Okay, so then the left-hand side is 2 to the what? Okay, and the right-hand side we don't have to mess with. It's 2 to the x squared. Are the bases the same? Okay, so the only way these two sides of the equation can be equivalent is if their exponents are also the same. So that means we're going to set those exponents equal to each other. How many answers are we looking for? Why 2?
X squared.
Because it's squared, okay, so don't forget that we have to have 2 answers here. So how do you get to them? Square root, okay, so we take the square root of the left-hand side. We got the square root of 8. Of course, it should be plus or minus square root of 8. Of course, that's not done because you should do what? Okay, so then what's the final answer here? X equals what? Plus or minus? Again, these are easy to check. Plug them in. 4 to the 4th is some number. Is that number the same as 2 raised to the 2 radical 2 squared? Is that okay? So far we've only had to mess with one side. That doesn't mean that's the only thing to do. Okay, sometimes you have to mess with both sides. So what's the base we're going to try to get to? 2. It'd be nice if we could just go to 4, but 4 to no power I know of is 8. Right, so let's go all the way to 2. So then 8 can be written as 2 to the what?
To the third.
2 to the 3rd. And 4 can be written as 2 to the
Second.
2nd. Right, now we do have the bases the same. Okay, so then this one is 2 to the... And this side is 2 to the... And again, the idea is that if this is an equation, that means both sides have to be equal to each other. Okay, so the only way that's going to happen, now that the bases are the same, is if the exponents are also the same. We're looking for 2 answers.
Square root 18.
Well, let's do something with the 2 first. Yeah, let's divide by 2 first. Okay, so then 9 equals x squared. Now we can square root 9. 3 and negative 3. That's right. Again, easy to check. Plug it in. See if 4 raised to the 3 squared gives you the same as 8 to the 6. It will. And so these are pretty basic ones. You know, we have to be able to solve for any exponent. And these only, you know, this is just the introduction thing. It'd be great if all numbers could just break down to the same bases, but they don't. So we have to do other things. But for tonight, you don't. You just have to be able to break the bases down to the same thing, set the exponents equal to each other. The next thing will be about logarithms.